Hi, this is our CS225 final project. My name is Liu, and for our group project, we are really interested in the world air traffic system, and we wanted to visualize how the airports and routes projected onto the world map. So we would use BFS traversal to help us do that. And also, we wanted to find the shortest path between two cities and also the shortest path through some landmark. So we would use Dijkstra algorithm for us to do that. And we want to output our BFS and Dijkstra as animation. Also, another interesting goal of our group is to make a graph so that there's as few cross edges as possible, and we wanted to simulate the motion of airports and routes as physical forces, so that we added the force-directed graph as our goal. And during our code implementation, we find another interesting topic, which is the importance of the airports. And we added the betweenness centrality as one of our group projects goals. And we managed to accomplish all the goals listed above. And because we are interested in flights and airports, we use the open flight data set, and we use our airports as nodes and routes as edges as in a graph.
Hi, I'm Dong Wang. This is our data input part. First, we read all data into a vector container. Here we create an input file stream object, then get the contents line by line. We read airports first. The airports are stored in a hash table to realize big O1 lookup time. The key is the IATA code of a specific airport. The value is a vector contains latitude, longitude, and altitude of the airport. We already read the world coordinates of airports. There is a private function local to graph to convert world coordinate to image coordinates. It uses a projection of latitude and longitude, ignoring the altitude. Here is a projection of all airports on the world map. Then we read valid routes. Here valid means we only accept routes from and to a known airport. We use a vector of string pairs to store routes. The first element is the code of start airport, and the second element is the code of destination airport. Here shows all the routes our airports. We build graph from routes and airports. The graph is directed weighted represented by adjacent list. We use hash table to realize big O1 lookup time. The key is a unique index for every airport. The value is a vector of int pairs. The first element is the destination airport. The second element is the distance between two airports. Distance is calculated using power sign method, which returns the distance of two airports on Earth. We use the extra algorithm to get the shortest path between two airports. The input is a code of two airports, and it returns the shortest path between the airports. Here is an example. We use breadth-first search algorithm to travel all the airports that you can arrive at from a specific airport. We show this process with our animation. Betweenness centrality is a way of detecting the amount of influence a node has over the flow of information in a graph. It is often used to find nodes that serves as a bridge from one part of the graph to another. The algorithm calculates unweighted shortest paths between all pairs of nodes in a graph. Each node receives a score. Based on the number of shortest paths that pass through the node, nodes that more frequently lie on shortest passes between their other nodes will have higher betweenness centrality scores. We use brand method to calculate the betweenness centrality of all airports. Based on the result, we find the top airports are very important in the world, like ORD, LAX, and PEK.
For the landmark problem, because we used a undirected graph, so we only have to use Dijkstra once, starting at the middle point. We try to implement the algorithm so that the Dijkstra stops when we reaches both the starts and destination points. But there are some errors occur when we append the two paths. So we just decide. So we choose to run Dijkstra at the middle point on all the airports, and that's something we can improve on.
Okay, Yong Ye, and here is my test case. And as you can see, we have 20 assertions in 10 test cases, and they are all passed. The first test case I want to introduce is to verify calculate distance in graph.cpp. Basically, we just use this website. You give the longitude and altitude of an airport, and the website will tell you the concrete distance of between these two airports, and we compare it with our function return, and it passed. The second test case I want to introduce is the shortest path function. Basically, we individually write the shortest path function, and we use one person's outcome to test another person's code. And we expect our routes to be YNA to YZV to YKL to YVP, as you can see here. And the return of the shortest path is vector int, and we require it to be this, and it's passed. The second test case is verify BFS algorithm. Again, we individually write BFS algorithm and use one person's output to test another person's code. If that pass, we merge two algorithms together. We start from SEA, which means Seattle airport, and we get the index of these airports, and the DFS algorithm should tell us all the airport index that from these stars can reach. Basically, YZG, YPO, and IRP are airports of the same level.
Okay, I'm Ian Zhang, and let me present the idea of the force-directed graph. In order to implement this function, we made several components as traction, repulsion, update coordinates, and data to choose. And it's made of centrality. Well, first thing we are going to introduce is initialization of the node. We generated X and Y coordinates randomly in a canvas of 800 watts and 500 height. And we store the data in a map called nodes. Also, we created a factor K, which is used to make the point suit in the canvas more for the following functions. Then we generated a function to calculate the repulsion. This is done by consider 2 points. The calculation is mainly done by considering the actual airport distance as weights between each point. This means that if the distance is large, they're going to be more far away from each other, and there seems to be a repulsion force happening. We use two maps to store the displacement, which should be imposed on each point, as the dx map and the dy map. And the next function is the traction force. After thinking a lot, we decided to use if there exists a route and there will be a traction force happen. We use the condensed factor to make the change more obvious. Then we go over all the routes and check if the 2 points of the routes exist in the airport's list. And then we minus distance between the points by changing the displacement in the dx and dy map to illustrate that there is a traction force between these points. And however, we encountered an error that some points may access the canvas, which is not what we want. So we add some constraint like this to make displacement not that large, like the middle parts of the function. And then we also, if there is a point access the given range, it will be shifted to another direction by the same distance, like it truly hits a wall. Well, but after we finally construct all the functions, it is not time for us to feel happy yet. At the first time, we considered all the roots and points. The lines almost make the graph all black and it is fully unreadable. So we use the centrality algorithm to choose the top 100 important airports. That's what we have done. It looks weird that some lines goes out of the graph in left and get in from right. Just consider it's a cylinder and there are the lines and of truly shortest distance. And we have everyone to say about the things we have learned from the final project.
I'm Rong Wang. From this project, I learned how to construct a complex program from scratch and implemented some advanced graph algorithms like between centrality and force-directed graph. In the future, I will implement more methods to visualize the results better.
I'm Ian Zhang, and I'm going to share my experience. We do really learn a lot from the final project, like the graph algorithms and things like force-directed graph input files, which we haven't learned ever before. It is my first time to do things with a team. We need to communicate, share different ideas, and solve plenty of different weird questions. This gives us a precious experience and shows us how engineers in real world work.
Hi, I'm Yong Ye. I'm glad to participate in the amazing project. I learned so much. Previously, I don't know how to design the whole structure of a project. I don't know how to make tests to verify codes. Also, I don't know how to cooperate with teammates. But now I do. I will surely benefit a lot from the experience.
I'm Wolio, and I'm really excited that I was a part of this project. And through this project, we actually get a better understanding of the Dijkstra algorithm. And also, we were able to research ourselves and achieve something on our own for the first time. So I think it's a great experience.
Thanks for watching. That's all.